Some of the inequalities will also involve horizontal and vertical lines. So in this first example, think about where y equals 3. It's right here, most people would say on the y-axis, but it also equals 3 here. The x changed, but the y is still 3. So as long as I move left or right, y remains 3, but the x changes. So whenever you have y equal to something, or an inequality, it's basically a horizontal line. That's every lattice point on the graph where y is equal to 3. And since there's an equal sign, I'll just draw a solid line through that. And then I'll write that y is big here and y is small here, and then ask myself right there that does y small or big based on the equation or the inequality. Since the alligator is not eating y is small, so that means I'd shade everything below for this graph right here. All right, now when x equals something, or x is greater than -5, most people would identify that x is in fact -5 here, but because this is x, I can go up or down, and even though moved up, x is still -5. Y changed, but x is still -5. So for every lattice point that x is -5, I could go up or down from here, and all along this line, x is still -5. The y changes, but the x is -5, and since there's no equal sign, technically this is supposed to be a dashed line anyways. So I just kind of fill in a couple of these with a dash. And then this is the first time we haven't had to talk about where y is big and small. This time we have to talk about where x is big and small. X is this axis right here, so x is small over here, and x is big over here. According to the inequality, the alligator's eating x, so x is big, so I need to shade the x half that's big, so that would be all the shading over here to the right. Now sadly your calculator couldn't graph this one because your calculator can only graph in function notation unless you have an inequality app, but let's just graph this first one to check it. So had I gone to y equals and typed in 3 and made the cursor point such that the arrow is pointing down because y is small, so press enter, enter, enter until the arrow points down. So that's what we type in. And then if you wanted to see this graphed, just hit zoom 6 or graph. And it's exactly like what we have right there. And again, you can't do this one in the calculator because it has x equals. It has to be set equals to y equals. All right, let's try somewhere we got actually graph a system of inequalities finally. So this first one basically tells me if it's in slope-intercept form, so no work really needs to be done here. I just need to start at -4 on y-axis. And then I also could tell that from this I need to rise after that, rise 1, and run 2. So let's try to graph that first inequality. So start at -4 on the y-axis. All right, there's -4 on the y-axis. Then rise 1 and run 2. Rise 1 and run 2. And you can continue doing that till you run out of graph paper. This also is the same thing as rising -1 and running -2. Because a negative divided by negative is still a positive. So if I rise -1, that's down 1, and run -2, that's left 2. And again, I can use all the lattice points up going that direction. And because there's no equal sign, this will be a dashed line. So let me just put some dashes in between these points. And then I'll remind myself that y is small down here and y is big up here. So according to this, I would need to make a graph where y is big. So I would shade above the line. I want to kind of do this lightly because I'm going to have to do a second line on the same graph to do a system of inequalities. All right, but before I can do that on this one, I first have to solve it for y to put it in slope-intercept form. So to do that, the easiest way to get y probably isolated, it would be to add 3 to both sides. That would leave me with, let's see, -2x plus 3. I had to kind of squeeze that plus 3 in there because these were not like terms, so I couldn't combine them. And then that's greater than or equal to, because those 3's are gone, just y now. So basically I already have y isolated. It's just written where instead of y equals, it's written at the end equals y, but it's still y equals mx plus b. So this is enough information to tell me that for this graph, I should start at 3 on y-axis. And this tells me right here that the slope for this one is rise -2, run +1. So -2 divided by 1 is still a -2. So let's try that one. Start at 3 and then I need to rise negative 2, so that's down 2, and I need to run 1, that's over 1. Rise negative 2 and run 1. Rise negative 2 and run 1. So if I continue that all the way until I run out of graph paper, it would take me down to about there. I could also say this is the exact same thing as rising positive 2 and running negative 1. The idea is that it has to be equal to a negative 2. 2 divided by negative 1 is still negative 2, so let's try that one. Rising positive 2 would be up 2, and running negative 1 would be left 1. And I'm ready to graph the line now, and since there's an equal sign, this will be a solid line. And for the purple line, I need to determine is y big or is y small based on that inequality. According to this, y is small, so that would be everything below the purple line. And since I'm graphing two inequalities at the same time, really the answer that I'm looking for is where do the two shadings overlap. And if you look carefully, they overlap right in here. I'm going to try to emphasize that as the answer, right, where the two shadings overlapped. And in all honesty, we could really, I guess, erase the parts that are not part of the shading. So you can see in here that that's where the two overlap each other. And again, of course, we could do this with our calculator to validate the answer. Let me bring my calculator up one more time. I just need to see all of it at the same time. All right, so here we go. So parentheses 1 divided by 2x minus 4. And then we need the second equation where it's y equals negative 2x plus 3. And then I need to simply go to the back of these and figure out what inequality to use. All right, so for the top one, y was big, and so I need the arrow to point up for y being big. For the second one, when we solved it down here, y is small, so I need to press enter until the arrow points down. And then just press graph. Here's the first, that's the blue line, and here comes the purple line. And you can see clearly that's where they overlap, and that would be the solution, is where they overlap. Right, again, it's always a good idea, if you would, maybe consider pausing the video and trying to do the next one on your own. And then when you're ready, you can unpause the video, but I'll go ahead and start on it now. So for this first top equation, I'll bring that over here to the side. I have 3y plus 2x is less than or equal to 6. So I'm going to start isolating the y by subtracting 2x from both sides first. And that leaves me with 3y, and then 2x and negative 2x cancel out, is less than or equal to negative 2x plus 6. And then I divide both sides by 3. So y is less than or equal to negative 2/3 x plus 2. And that gives me all the information I need to graph that line, because this tells me here that I should start at 2 on the y-axis. So I'd start right there. And this tells me that I should rise negative 2 and run 3. So rising negative 2 would be down 2, and running 3 would be over to the left 3. Rising negative 2 and running 3, and that's all I can fit. I could also rise positive 2. Remember how we can just flip the signs. I could do rise 2 and run negative 3. The end result that still is a negative 2/3. So to rise positive 2 would mean up 2, and running negative 3 would be left 3. And since this has an equal sign, we'll do a solid line. And remind myself again that y is big here, and y is small down here. And according to the inequality, I need to graph this where y is small, because y is not being eaten. So since y is small, I shade below. Again, I don't want to do it too heavy because I'll probably erase some of this after I figure out the other line. Now the second line, again, isn't solved for y, so it's pretty easy to fix that. All we need to do to isolate the y would be to add 4 to both sides. And I really think this could be a typo, but it's all right, we'll go with it. I just realized I don't have x and y, I just have y. So actually it might make more sense in this case to subtract y from both sides. Okay, so if I subtract y to both sides, what do I have left? I have 3y minus y, which is 2y, is greater than negative 4. And then I still don't have y isolated just yet, so I'll divide both sides by 2, which will leave me with y is greater than negative 2. So this is kind of going back to like the problem above. I got to show all the places where y is negative 2. Y is negative 2 right here, and anywhere left or right of that y is still negative 2. And so this is going to be a dashed line at y is equal to negative 2. That's a dashed line. And then y is being eaten, so y is big. So for the purple line, I need to go where y is big, and that would be above. So if I go above the line right here, that would be everything here and up. But again, if you look, I'm just looking where they overlap, and you can see the overlap occurs right in here. Do you see I have blue and purple in there? So I'm going to erase that now that I've identified where the overlap is. So the overlap is right in here, where the two inequalities overlap each other is right there. And I'm emphasizing this. Again, we can check this with our calculator because at least it's a y equals. So let's try this in the calculator. So the first equation, let me go to y equals and clear out the old stuff. I'll type in this first one, which is parentheses negative 2 divided by 3 x plus 2 and negative 2 for that y right there. Now I'm going to set the inequalities behind those y's. So here y is small because it's not being eaten, so I'll press enter until the arrow points down. And here y is big, so I'll press enter until the arrow points up. And then graph that to see if it doesn't look very similar to what we have. So there's the blue line being graphed, and there's the purple line being graphed, and you can see they double up and overlap right where we had shaded. I hope this was helpful. I'm going to stop here and start the next video. Please ask me if you have any questions.